All right, guys, welcome to another episode of CUDA Education. Um, Today, I want to do a quick overview of the ray tracing shadows algorithm. So, the ray tracing shadows algorithm is dealing with displaying shadows in a ray traced scene. So we have a ray traced scene and we are displaying shadows in the scene. All right, so this is ray tracing shadows.cpp. Okay. And this is CUDA Education, of course. And first of all, if you guys want to join in on sort of being able to run these examples on your Windows-based machine with a Vulkan-capable GPU, you need tutorial number 1 and tutorial number 13. So this is the Vulkan API, and this is the to install several examples. Okay, so that's that. All right, so I want to just quickly go over what we're dealing with as it relates to our application. So again, we are rendering shadows. That is a priority of this script, of this algorithm, of this example, and of this discussion. Okay, so I'm gonna do a very simplified version for my I'm gonna do a very simplified version for my whiteboard example here. Just because, I'm not artistically inclined and all that stuff, but I want you guys to be able to follow exactly what, I'm doing. All right. So we're talking about shadows. We're generating rays that are traversing a scene, and we want to be able to generate shadows, realistic shadows, right? So it's not artificial shadows. We're not artificially placing shadows anywhere. We want these shadows to naturally be generated from the rays that are traversing the scene. Okay, so again, we're not, this is not the 1990s or something where we're artificially creating shadows, right? We're not doing that. What we're doing is we're shooting rays into a scene, and wherever the shadows lie or the shadows are generated naturally, organically, then that's what happens. Okay, so again, I'm gonna do this basically as a very simplified version. So let's say we have a hammer here, right? And this is like a very a very basic kind of hammer. Okay, we have a hammer here. All right, so this is our hammer, right? And made the hammer too big maybe, but we have our hammer, and we have a light source, okay? So we have our light source. So let's say over here, we have our light source, right? So this is our light source, okay? So this is our light source. We have a hammer, and then because of the light source and the hammer, we cast somewhat of a shadow, right? So of course, I'm just gonna do a miniaturized version here, and this is our shadow, right? Right, so this is our shadow. Okay, so we have our light source hitting the object, and this is the shadow, right? So we're gonna call this the shadow. Shadow. This is our object. And obviously the shadow is sort of behind the object, right? I apologize for any orientation, any 3D, whatever, sort of, yeah, I apologize for that. Okay, so we have our light source, we have our object, and we have our shadow, okay? What we need to do is now discuss some rays. So, you know, as previously in the previous videos, as it relates to this example, we have our we have about 4 different shaders, right? We have our raygen shader, which is pixels initially traversing the scene, right? Rays are generated and it's traversing the scene, right? So that's raygen. We have our mist shader, so rays that traverse the scene and doesn't hit anything. We have our background color or our background model, right? In this case, we could say our background color is white, right? It's the whiteboard here, here, here. Rays traverse the scene, it doesn't hit anything, you know, so therefore it is, you know, the background color is white. All right, so we're traversing the scene and we get white as our background color, our sky model, however you want to call it, right? We have our hit shader, so that's rays traversing the scene and it hits an object. So all rays that traverse the scene within this region is going to hit this object, right? So this is the region where we record hits. Okay, so we have our raygen shader that generates rays into the scene. We have our mist shader that basically deals with any rays that traverse the scene and doesn't hit anything. We have our hit shader that basically when it traverses the scene, it hits an object in the scene and it does special processing according to what we outline in the hit shader accordingly. And then we have our what I like to call the shadow mist or the mist shadow shader. And that basically is handling what happens when we hit something and then we hit something or we traverse the scene to a point and then we cast an extra shadow ray between the point that we're investigating and the light source. But I'm getting ahead of myself. Let's not dive too much into the shadow mist or the mist shadow shader mist, the shadow mist shader. Okay, let's not dive into that too much right now. But just understand there are 4 shaders: raygen, mist, hit, and shadow mist. Okay, all right. The first thing we need to understand is that the ray generation, the primary ray, right? So we have actually, let's so we have raygen, we have miss, we have what we call the closest hit. You know, I just refer to it as the hit shader, and then we have the shadow miss, the shadow miss. So these are all our shaders. Okay, so these are the shaders. Okay, raygen, miss, closest hit, what I call hit, and the shadow miss. Okay, so we are ray generation doesn't come from the light source. That's the first thing we need to understand. Ray generation doesn't come from the light source. The rays that are generated into the scene comes from the camera, right? So our view of the application, our view of what we're seeing in the scene is where the rays come from. It's basically being shot out of the camera, or you can think of it as it being shot from your computer monitor. So your computer monitor is shooting rays from your computer monitor into the application window, and whatever it sees is what it sees, right? So that is where ray generation comes from. It is not, I repeat, it is not from the light source. That is not what the light source is about. Ray generation comes from our camera. Now, in the application that, and you can see it from the previous videos here, you know, the previous videos directly before this one, the rays are being shot from the camera. In the application, you could actually rotate the platform or the object. Okay, so we have, you know, we have these objects on sort of a platform or an object, and we are we're shooting rays, we're shooting rays from our camera into the scene, right? So when you rotate the object in the camera, when you rotate the object, you know, you're actually shooting rays, you know, from a different place, right? So obviously your vision of the object and your vision of everything that you see is going to change, because it's going to change because you know, you're looking at a different situation. Okay, so one of the things that I want to add to this discussion actually is sort of, you know, in the background, we sort of have like a platform. Let's say the platform is, it's just you know, it's just a platform. It's just a platforming space that the objects and everything sit on, or sort of, you know, sits on, okay? So, you know, we do have our sky model and stuff, but we do have like a platform. So let's just put the platform like this, okay? All right, so this is sort of our platform. This is just what you call, you know, our platform. All right, it's just something that everything sits on, and is the reason I need to create this is because I want to demonstrate a couple of things, and I need to differentiate between what is the sky model, what is the complete miss, and what is hitting, you know, the background of you know, what is hitting the platform, okay? But it's sort of ancillary to our main focus. But I do need to have like a background, you know, like a platform, just to demonstrate my thing. So rays that are generated from our camera into the scene is coming. It's basically what we call the primary ray. Okay, so the primary ray comes into our scene, and we and these primary rays basically initiates everything. So let us, for example, we're gonna draw a ray, because we're looking at it from this angle right here. Okay, so let us draw a primary ray, right? Let us draw a primary ray right here, okay? So we have our primary ray right here. All right, so we'll just call this primary ray, right? So this is our primary ray, okay? So we have our primary ray, all right? Now what happens is that the primary ray is going to hit this object, okay? So it's going to hit this object, right? So we're going to record a hit right here. And then what happens is that another ray is generated at that point of hit, okay? So we hit the object here, and then when we hit this object, we generate a second ray, all right? So let me clean this up a little bit. All right, so we have our primary ray, and we record a hit right here, right? So it's a primary ray, but we record a hit, okay? So when we hit something, like it's actually an object in our scene, we generate a second ray. Now this second ray is going to be called our, what I like to call it, the shadow test ray. Okay, so the second ray now at this hit point is called the shadow test ray. And what the shadow test ray is, it's going to be a ray that originates from the hit point all the way to the light source. And I'll tell you in a second why we have to do that. So it's a ray originated from the hit point going all the way to the light source, okay? And this is what I like to call the shadow test ray, okay? This is the shadow test ray. And what this shadow test ray is doing is it is testing between our hit point and the light source. Are there any objects intersecting between our hit point and the light source? Are there any objects intersecting between our hit point and the light source? I apologize for the 3D orientation and everything, but for our example right here, there is no intersection. Okay, so there is no intersection between our hit point and the light source, right? This is not obstructing anything, right? So there is no intersection between our hit point and the light source. So if there is no intersection, then we deem the point, this point, to be lit. So no intersection equal lit. So basically it's bright, it's illuminated, it's lit up, it's on, right? It's not shadowed. If we have an intersection, then it is shadowed. Okay? So no intersection, it's lit. If there is an intersection, then it's shadowed. Okay? Maybe not an equal sign. Maybe I put a question mark. Okay, so no intersection lit, intersection shadowed. So here, this point is deemed as being lit, right? So I'm gonna put lit here. So this test is lit. Okay, lit, right? This point is lit, right? Because there is no intersection between our object that we hit and the light source. Okay, now this guy is behind, sort of, and maybe what I should do is I'm just gonna redraw this thing because it will make it easier to understand. So I'm gonna redraw this thing. All right, so maybe I'll do I'll just do it like, because it's sort of really behind. You know. But this, just think of this guy as being behind it's behind the this is the shadow, right? So this is all behind the object, right? Now how does the algorithm know that this is a shadow? How does it know that it's a shadow? Because I gotta re-engineer everything, guys. I gotta re-engineer everything. All right, this is our primary array. Right? So because the thing about it is that when we have our primary array coming in here now, So when we have our primary ray coming in here now, we're gonna see that when we have our hit right here, and then we try to draw our shadow, that there isn't all right, that there isn't and this is a hit, right? So we get a hit. That there isn't any that the shadow ray doesn't hit our light source. It hits the object in front of it. So when our shadow ray tries to go from our intersection point, from our hit point, all the way to the light source, it's being blocked by the object in the middle. And this is how we know that this point is unlit. So this point unlit. And we know that because from the hit point all the way going to the shadow, all the way going to the light source, the object blocks it. So it is considered unlit. Okay? It is considered unlit. All right? So here, our primary ray comes in, we generate a shadow test ray, and it's lit because there's nothing intersecting between our hit point and the light source. Here, primary ray comes in, we try to go from that point to the light source, and we hit the hammer. So therefore, this part is unlit, which means it's basically its shadow. It's casting, this object is casting a shadow because it's blocking shadow test rays from this point to the light source. And that's how we know that this part is a shadow. Now, in the actual application that I have in previous videos, the light source is actually moving, in a circle around the scene. And as the light source moves around the scene, you see the shadow move with it, which is natural, right? Because every time we do a hit in any part of the space, we're doing a shadow test. And depending on where the light is and where the shadow test is being done, it determines whether this is a lit place or not. So for example, if the light source wasn't over here and the light source was over here instead, this point would be considered lit. There wouldn't be a shadow here because at this same point, the shadow test will go towards this light source and it would be uninterrupted. It would be unobstructed. You would basically have the light source covering all of this area, so there wouldn't be any shadows here. But the light source is over here and the shadow test is being run to test whether from that point to this light source, if there's anything interrupting it. And yes, there's something interrupting it. It's the hammer. All right, so that is that. The reason why I needed to create this platform, though, is because the reason why this primary ray hits here, it's not hitting here because it has psychic powers and it knows that this is going to be a place of a shadow. What it's really hitting, it's hitting the platform. You see what I'm saying? So this is a platform that's sort of where everything, where the whole game or the whole scene or everything is sort of, it's a part of, right? So the object sits on a platform and then the shadow is cast onto the platform, right? So this hit right here is not, you know, it has to hit something, because if this ray continued throughout and you didn't have a platform, it would basically be rendered as a sky or a background color. And it would render as a sky or background color because you wouldn't hit anything. But we have to have the platform so that we register a hit here, and then because we register a hit here, then we could do the shadow test ray. All right. Now, in the application, I don't know why this was done this way, but in the application, as soon as we generate a primary ray, or as soon as basically the scene is, the application is started and the scene and the primary rays and everything is generated, everything is assumed to be shadowed. And really what the shadow mist shader is doing, the shadow mist shader is basically saying, hey, this point right here is actually lit. That's what the shadow mist shader is doing. It's saying, hey, this point here is lit, so change the designation for this point to shadow equals false, right? Everything is assumed to be shadow equals true. In the closest hit shader, everything is assumed to be shadow hit true. Okay? I mean shadow, right? Shadow is true, right? But then depending on what happens and what goes on with the shadow mist shader, the shadow status could be turned off. I don't know why it's done that way, but that's how the example runs it. Okay? So that's pretty much how shadows work. It's actually not that complicated. Like, I thought it would have been a lot more involved, but it's a pretty cool example. Again, guys, if you want to be able to run these examples, you got to get tutorial number 1 and tutorial number 13. You have to be, it's a Windows machine, Vulkan-capable GPU with ray tracing capabilities. For NVIDIA, it's RTX. I can't talk about the other vendors, Intel and AMD. All right. But that's pretty much it. So if the shadow test fails, we know it's a shadow. And if the shadow test, if the shadow ray basically can go to the light source, then we know that that place is lit. So even though this is a dark hammer, the dark hammer is lit. And here it casts a shadow. So all of these places, all of these points around here, the shadow test ray or the shadow ray, it doesn't reach the light source because it's obstructed by the object that it's displaying the shadow for, right? There has to be communication between the closest hit and the hit shader and the shadow mist shader. And I do that, I talk about that in the previous video. It's ray payload ext and ray payload in ext. But I talk about it in depth in the previous video. I'm not gonna rehash it here. But notice that there has to be variable sharing between the primary ray and the shadow test ray or the shadow ray. Okay? There has to be communication, and we do that by means of ray payload ext and ray payload in ext. But again, the previous video deals with that conversation. I probably will link it down below also, so you guys could quickly see what I'm talking about. And that's pretty much how shadows work. For these guys, so let's say, I don't know if you could see, but let's say I do primary ray here. The thing with this ray is that it doesn't intersect anything. I don't know if you could see it. I'll just do it down here, right? It doesn't intersect anything, right? So because it doesn't intersect anything, then that's where the mist shader comes in, right? So it doesn't intersect anything, so the mist shader basically takes care of that one. All right, so we have our primary rays that come in, that's generated from the camera, from our eyes, from the monitor. If we hit something, we do a shadow test, right? And if there's no interruption between that point and the light source, then we get a lit area or region or pixel. But if there is interruption, if there is obstruction, an intersection between that point and the light source, in this case, this hammer right here, then we get an unlit or shadowed, shadowed, right? So it's unlit, shadowed, what have you. And there you have it, guys. So normally for ray tracing applications, we have 3 shaders. Here we have 4. Because we have to deal with this situation. In the hit shader, the hit shader is what, so this hit shader is what calls the shadow test ray or the shadow ray, right? This hit shader, right? Because we generate the primary, and then upon hit, the hit shader generates this extra ray, and then the shadow mist is dealt with and stuff, right? And that's the way I see it, guys. Anyway, so that's it. So this computer graphics stuff, it's not too complicated. I actually feel that the ray trace stuff is a little bit easier than the non-ray trace stuff, because you're basically generating rays and letting the chips fall where they may, right? That's like an oversimplified version, but really that's what it is. You don't have to necessarily do a lot of processing yourself and creating stuff and moving stuff. It's sort of like you generate the rays, you guide, what happens when events occur in the application, and that's it. For the non-ray tracing stuff, it's a little bit more involved because you kind of have to take care of everything, That's just my opinion anyway. I'm learning this stuff just as much as you guys are. So yeah, tutorial number 1 and tutorial number 13, guys, get involved in this stuff. If you're creatively inclined, if you're an artist, if you like drawing, if you like illustration, if you're a scientist, if you want to impress the people in your department, in corporate, whatever, you gotta be able to put pixels on a screen. Yes, an Excel spreadsheet is wonderful. Yes, a PowerPoint presentation is wonderful. And yes, tables and diagrams and whatever is great. But if you could generate a computer simulation of what you're talking about, a visual, moving simulation of what you're talking about, you're gonna be gold. Right? And you're going to make the company look good, you're going to make your department look good, and you're going to, it's the future, right? AI can do a lot of things, but it can't do creative stuff. It can't do things that it has never seen before. It can only sort of regurgitate what it's been trained on, right? So, computer graphics, guys, you guys learn computer graphics, invest the time to learn computer graphics. It's pretty cool, actually. All right, guys, that's it for today. Thank you for watching. This is CUDA Education. Have a great day. Tell your friends. Share this video. You know what to do about the channel, all that good stuff. Let me know if you have any questions, what have you. Get this application running on your machine. Get this application running on your machine so you could play around with this stuff. You could play around with the shadow test. You could play around with the light source, the position of the light source with the test. You know, whatever you want to do. Best way to learn Vulkan is to have running code on your machine. All right, guys, have a good day. Bye.